Good morning, my dear friends. I hope you all are doing great. So today we'll be talking about the temperature, heat capacity, specific heat capacity and molar heat capacity. So let us start with the temperature. What is temperature all about? Have a look. Temperature, the degree of hotness or coldness of an object. So what is temperature, my dear friends? Temperature is basically the degree, the amount of hotness or coldness of an object. For example, if any substance is very hot, so that means it is at high temperature. Yes. If substance is cold, it means that it's at low temperature. So temperature is basically the degree of hotness or coldness, my dear friends. Have a look here. Let us suppose if I have water in this particular beaker. Okay. I want to check the temperature of this particular water. Let us suppose here this is hot water. And obviously the temperature will be high. We are aware. If this is a hot water, I want to check the temperature of this particular water. So in order to check the temperature, I have to use a device called as thermometer. So I will use thermometer to check the temperature. Thermometer is used to check temperature. So by using thermometer, let us suppose the temperature of this particular hot water is, let us suppose it is 70 degrees Celsius. Yes or no? But remember, the SI unit of temperature is not degrees Celsius. The SI unit of the temperature is Kelvin. So whenever you are doing the numericals basically in the chemistry, you have to always convert this degree Celsius into Kelvin. So how to convert this degree Celsius into Kelvin, my dear friends? You know that 0 degree Celsius is equal to 273.15 Kelvin. So now I have a temperature with me 70 degrees Celsius. So 70 degrees Celsius temperature is equal to 273.15 plus 70. So my dear friends, this will be your temperature in Kelvin, my dear friends. So if we just try to get the equation done right out here, it will be 5, 1, then obviously 3, then you have 14 here, then you have 343.15 Kelvin. So 70 degrees Celsius temperature is equal to 343.15 Kelvin temperature, my dear friends. So now we know the temperature of this particular hot water is 70 degrees Celsius. And now let us take cold water here. Let's suppose this is the cold water. Again we will use the thermometer to check the temperature. And let us suppose this cold water is at 1 degree Celsius temperature. So which device you are using for checking the temperature, my dear friends? Thermometer, obviously. And you have seen in thermometer there will be a mercury. Yes, that mercury level will rise. And that rise in mercury level in thermometer will give you that there is a temperature rise actually. Are you following or not? So if the temperature of the substance is very high, then the mercury level will go very high up. Yes or no? So in the same way, in basically cold water, the temperature, let us suppose, is here 1 degree Celsius, my dear friends. So let's convert it into Kelvin. So it's 273.15 plus 1 degree Celsius. So it will become in Kelvin. So it's 274.15 Kelvin, my dear friends. Look here, if you put the thermometer in hot water and the mercury level has risen, okay, and it has stopped at 70 calibration. then understand 70 degrees Celsius is the temperature of that particular water. So now, my dear friends, after discussing about hot water and cold water, yes, now let us talk about now heat. It's a form of energy which flows from one object to the other object. Heat is a form of energy. It can flow from one object to the other object, but only when there is a difference in temperature. Now if you look at hot water and cold water, heat can flow from hot water to cold water, and there is a difference in temperature. How much is the temperature here? 70 degrees Celsius. How much is the temperature here? 1 degree Celsius. That means heat can flow from here to here, from hotter object to colder object, because there is a difference in temperature. Yes, have a look here, my dear friends. Let us suppose I have here hot water. Let's suppose this hot water, and the temperature is basically here, let us suppose 70 degrees Celsius is the temperature, correct, for this hot water. What I'm going to do that, let's look into the surroundings. What is the temperature? This is our system. Let's look into the surroundings. Let us suppose in surroundings we have 25 degrees Celsius is the temperature, and inside this system, my dear friends, the temperature is 70 degrees Celsius. Let us suppose. So there is a temperature difference between system and surroundings. So what is heat? It's a form of energy which flows from one body to the another due to their temperature difference. Now there is a temperature difference between system and surroundings. Okay, so what will happen, my dear friends? The heat will flow from system to surroundings. So there will be a flow of heat from system to surroundings because there is a temperature difference between them. Yes. So my dear friends, now if you look at the SI unit of heat, SI unit of heat is joule. And remember, 1 calorie is equal to 4.184 joules, my dear friends. Now what is my point here, man? That is, heat will flow from the hotter object to the colder object. Let us suppose in surroundings we have air. So the heat is flowing from water into the air. Air is present in the surroundings. So from hotter object to the colder object, heat can flow. But if two substances are at same temperature, two objects are at same temperature, then heat will flow from A to B and B to A. That means the heat flow will be bidirectional. That means the two objects are actually at thermal equilibrium. Remember that point. When two objects are at same temperature, what is the temperature difference then? 0. When temperature difference between two objects is 0, yes, heat will flow there also, but it will flow in bidirection, like from A to B and from B to A. So net flow of the heat will be taken as what? 0, because it's flowing from A to B and B to A. So net flow of the heat is 0. So remember that particular thing, my dear friends. Please make note of this. Dear friends, let's talk about heat capacity. What is heat capacity all about? Have a look. The amount of heat required. Okay. And you know that the heat is mentioned by Q. So Q is the heat. To raise the temperature of a given mass of substance. When you are raising the temperature, that means you are changing the temperature, and change in temperature is represented by delta T, my dear friends. And now here, for a given mass of a substance, by 1 Kelvin or by 1 degree Celsius, my dear friends. So a mass will be given to you of an object, correct or not? So let us take on some water here. Let us suppose we have water here. And the mass of water will be given to you people. That means they can give you, let us suppose, in terms of volume, if we talk about, they can give you 1 liter of water, 2 liters of water, 3 liters of water. But in terms of mass, if we talk about, let us suppose we have 1000 grams of water. Or we may have 10 grams of water. We may have 20 grams of water. So this mass is not specific here. Try to understand. They can give you, okay, any amount of the mass, when you are doing actually the experiment based on the heat capacity, any amount of mass can be given to you, and you have to only do one thing. You have to raise the temperature of a given mass of substance by 1 Kelvin or by 1 degree Celsius. That much only you have to do. Let us suppose by using thermometer, we will check the temperature here. Let's suppose the temperature of this particular water, okay, is, this water is at 20 degrees Celsius temperature, my dear friends. So what I am going to do is that I have to supply the heat. When I supply the heat Q, correct? So what will happen? The temperature of this water will increase. But how much I have to increase the water temperature? I have to increase the temperature of a given mass of substance by 1 Kelvin. Yes or no? Or by 1 degree Celsius. So if it is 20 degrees Celsius, by the application of heat, this will be your actually initial temperature. And after the application of heat, when you are applying the heat for this water, now temperature, let us suppose the final temperature has become now 21 degrees Celsius, my dear friends. So tell me, what is delta T here? Delta T is T final minus T initial. And how much is that? 21 minus 20. How much is that? 1. So the change in temperature is 1 degree. That means you have increased the temperature of a given mass of water. Yes or no? And this is the water, and this is the mass of water which is given to us. Yes or no? And now you'll be thinking that what is this given mass? Given mass means basically you can take 1 gram of water, 10 grams of water, you can take 1000 grams of water, but you have to raise the temperature of a given mass of substance by only 1 degree Celsius or by 1 Kelvin, my dear friends. Let us suppose I will take here 1000 grams of water. Yes or no? So I am raising the temperature by 1 degree Celsius. Now my dear friends, what is the expression for the heat capacity? The symbol for the heat capacity is C. So C is the heat capacity symbol. So C will be equal to Q upon delta T. What is Q? Q is the heat supplied to the given mass of a substance, and delta T is basically the rise in temperature. So this guy is your heat capacity. Okay. This is the heat supplied to a given mass of substance, and delta T is rise in temperature by 1 degree Celsius. So this is the equation for the heat capacity, my dear friends. Now there is one question here. Let us suppose in laboratory or under experimental investigation, if you take, let us suppose, 1 gram of any substance and you take 10 gram of any substance, correct? Let us suppose you are taking 1 gram of water and you are taking 10 grams of water. Yes or no? Here also you want to have delta T equal to 1 degree Celsius, and you want to also have delta T equal to 1 degree Celsius here. That means you want to change the temperature for this substance by 1 degree. You are increasing temperature by 1 degree. And here also you want to increase the temperature by 1 degree Celsius. So how much of heat is required here, my dear friends? I will supply the heat here and I will supply the heat here. Okay. Here, how much is the rise in temperature? 1 degree Celsius. How much is the rise in temperature? 1 degree Celsius. So my dear friends, it's positive, so it's a rise in temperature. So this is basically rise in temperature. But here you are applying heat for 1 gram of substance. Here you are applying heat for 10 gram of substance. Temperature change is 1 degree Celsius, temperature change is 1 degree Celsius. But do you think the heat capacity of 1 gram and heat capacity of 10 gram will be same? No. The point here is that for 10 gram of substance you require more heat. Yes or no? To increase the temperature by 1 degree Celsius. And for 1 gram you require less heat to increase its temperature by 1 degree Celsius. What is the meaning of that? If the mass of substance, given mass is more, then more heat is required to raise the temperature by 1 degree Celsius. So it means that the heat capacity depends upon the mass of substance. Yes, greater the mass of substance, greater is the amount of heat required to increase the temperature of that particular substance by 1 degree Celsius. So I will mention here, my dear friends, heat capacity is an extensive property. Yes, so I will write down mass of a given substance, yes, will be directly proportional to heat capacity. If the mass of substance is more, the heat capacity is also more. So which substance will have more heat capacity? So 10 gram will have more heat capacity than 1 gram. But rise in temperature will be 1 degree here also, here also. So here more heat is required to raise the temperature by 1 degree. And here less heat is required to raise the temperature by 1 degree. That means more the mass of a substance, more will be the heat capacity. And heat capacity is an extensive property, my dear friends. And what will be the SI unit of the heat capacity? So if we talk about the SI unit of heat capacity, we know that heat capacity is equal to Q upon delta T. Q is measured in joules and delta T is the temperature measured in Kelvin. So joule per Kelvin is the SI unit of heat capacity. Please mention this particular thing. So dear friends, let's talk about now specific heat capacity. Let me mention it by small c. So I am mentioning it by small c or small letter. Okay. Let's mention it by small letter. Now what happens actually in specific heat capacity, my dear friends? It is the amount of heat required to raise the temperature of 1 gram of a substance by 1 Kelvin or by 1 degree Celsius, my dear friends. Actually, in place of 1 gram of substance, you can also mention unit mass. So in place of this, you can also mention unit mass. At some places you will find out it's 1 kg. Yes. At some places you will find it as 1 gram. So both are actually unit masses. 1 kg and 1 gram. So let's look at this definition. The amount of heat required to raise the temperature of a 1 gram of substance. In heat capacity you were learning a given mass of a substance. Yes. So whatever is given you in the laboratory, you have to raise the temperature of that given mass by 1 degree Celsius. But here it's with respect to 1 gram. So it's a specific. It is only with respect to 1 gram of substance. Yes. So my dear friends, if I increase the temperature of 1 gram of substance by 1 Kelvin, this is called as specific heat capacity, my dear friends. So this specific heat capacity, will take it as a small c. And we will write down the same expression, Q upon delta T. But we know that we have 1 gram of a substance. So mass of substance is already mentioned, that how many grams are there. So it's specific. So here at this point, we will mention here M. And M will stand for the unit mass. This M stands for unit mass. And this unit mass we have actually 1 gram. And delta T, everybody knows it's the rise in temperature. Or you can also say change in temperature by 1 degree Celsius. And this Q is nothing but it's the heat supplied. Okay. What is this C all about? Yes, you can mention this C also as CS. S will stand for your specific heat capacity. But I have written it as a small c, so that's enough. So this is your specific heat capacity. So in specific heat capacity, my dear friends, I have to take unit mass, 1 gram of a substance, and I have to raise the temperature of that 1 gram of substance by 1 degree Celsius or by 1 Kelvin. And that is called as the specific heat capacity of that particular substance. So if I write down the SI unit of this, my dear friends, so Q will be basically joules, and mass is basically will be here in grams. Yes. If it is in kilojoules, then you can write down kg. So mass of an object will be in grams basically, and then temperature, change in temperature will be in Kelvin. Yes, my dear friends. So this is the SI unit of what? Specific heat capacity. So this I can call it as SI unit of specific heat capacity. So my dear friends, I hope you have understood. So remember this expression. I have to take 1 gram of a substance. I have to supply the heat to that 1 gram of substance, and there should be the increase in temperature by how many degree? 1 degree Celsius, and that is the specific heat capacity, my dear friends. And remember, this specific heat capacity is with respect to only 1 gram of a substance. Yes or no, my dear friends? So that's why it will become the intensive property, not an extensive property. So this is an intensive property, my dear friends. Okay, please have a look and just make note of this. Dear friends, now we can talk about specific heat capacity. Specific heat capacity at constant value. And we can also talk about specific heat capacity at constant pressure. We know the expression for this specific heat capacity at constant value. We know already the expression for the specific heat capacity, that is small c is equal to Q upon M into delta T. And we know obviously the expression for the specific heat capacity, that is C is equal to Q upon M into delta T. So my dear friends, these are our expressions. But here I am talking about the specific heat capacity at constant value. So I will mention this C as CV here. So here also I will mention QV. That means this is the heat supplied to 1 gram of a substance, yes or no, to raise its temperature by 1 degree Celsius at constant value. So I can define it like this, have a look. Okay, specific heat capacity at constant value is the amount of heat required to raise the temperature of unit mass, that means 1 gram of substance, by 1 Kelvin or 1 degree Celsius, my dear friends. So now this is the expression for your specific heat capacity at constant value, and this is the heat absorbed at constant value, and this is the mass of a substance, that is 1 gram, and this will be the rise in temperature, my dear friends. So CV is the expression here, so I will write down here CV is the expression for this, correct? And here is QV, that is heat supplied at constant value. Now this is at constant pressure, so this will become Cp and this will become Qp. So definition is that it is the amount of heat required to raise the temperature of 1 gram of substance by 1 degree Celsius or 1 Kelvin, my dear friends. So it's the amount of heat required to raise the temperature of 1 gram of substance by 1 Kelvin or 1 degree Celsius. I should mention this is important here. at constant value. This term is important, please remember. So here at constant pressure. So this term is important. So my dear friends, now you look here. This is the specific heat capacity at constant value, which is equal to heat absorbed by the system at constant value divided by 1 gram of substance, that is a unit mass of substance, into the rising temperature. Okay. Same thing, Cp is equal to Qp upon m into delta V. Please make note of these two expressions. So let's talk about now molar heat capacity. So my dear friends, what is this all about? The amount of heat required to raise the temperature of 1 mole of substance by 1 Kelvin or by 1 degree Celsius. So it's the amount of heat required to raise the temperature of 1 mole of substance by 1 Kelvin or by 1 degree Celsius. See here my dear friends, molar heat capacity you can represent like this also. Let's take on a capital C here, and then we can mention here N. This N will stand for number of moles. So this N will stand for number of moles. So let's talk about this. C is basically a capital letter here. You can represent it in your own way also. Yes? So let us represent it like Cn. C stands for capital letter here. Basically this is a capital C, and N is nothing but number of moles. So this will be your molar heat capacity. I have to raise the temperature of 1 mole of substance by 1 Kelvin or by 1 degree Celsius. So capital C will write down and N. Okay. That's equal to, my dear friends, same expression Q upon delta T. Here we are not, in previous expression we were using M, that was the mass, unit mass. So we were raising the temperature of 1 gram of substance by 1 degree Celsius when it was specific heat capacity. But here we are actually raising the temperature of 1 mole of substance. So for 1 mole of substance I will write down N. N will give me basically, it is number of moles. And we know here we have only 1 mole. So we have here 1 mole of a substance. So Cn will stand for the molar heat capacity, that is Q upon N into delta T. So my dear friends, it is basically the heat supplied, okay, to raise the temperature of what? Yes, to raise the temperature by 1 degree Celsius for 1 mole of substance, my dear friends. So it's all about that. This is 1 mole of substance and this is rising temperature and this is the heat supplied, correct? So heat supplied to 1 mole of a substance to raise its temperature or to rise its temperature by 1 degree Celsius, that is the molar heat capacity, my dear friends. Now, what will be the molar heat capacity at constant, you know what, value and constant pressure? That we will discuss. But before that we can discuss also SI unit here. For heat we can say joules, and for N stands for basically mole, so we'll write down mole. Yes. And delta T is basically measured in Kelvin. So it's joule per mole per Kelvin is the SI unit of what? Molar heat capacity. Now let us take molar heat capacity at constant value. So molar heat capacity at constant value will be taken as C N, let me mention here V. So if you don't want to mention this N, that's also okay, because you already know that we are taking molar heat capacity at constant value. You can write down directly CV. That way also you can mention. So you already know that this C is the molar heat capacity, so mention CV here. Yes. So at constant value, it will be equal to QV upon N, number of moles, which is equal to 1 basically here, delta T. So this is the amount of heat required to raise the temperature of 1 mole of substance by 1 Kelvin or 1 degree Celsius, my dear friends. So this is important, at constant value. So here we are keeping the value constant. Now if we talk about now molar heat capacity at constant pressure. So molar heat capacity at constant pressure, my dear friends, it will be taken as Cp is equal to Qp divided by N delta T. Qp is heat supplied at constant pressure. This is heat supplied at constant value. Okay. So what is the definition here? Amount of heat required to raise the temperature of 1 mole of substance by 1 Kelvin or 1 degree Celsius at constant pressure. You can mention it like this also. The symbol for this, you can mention it as CNV like this, or you can mention directly CV. And here you can mention for this as CN3, or you can directly mention CP. Correct? So my dear friends, I hope you have understood. Yes, this is at constant value and this is at constant pressure, and QV is the heat supplied at constant value to 1 mole of substance to rise its temperature by 1 degree Celsius, and this is the heat supplied at constant pressure to 1 mole of a substance to rise its temperature by 1 degree Celsius, or to raise its temperature by 1 degree Celsius. So this is all about the molar heat capacity, my dear friends. Dear friends, let's take some examples now to understand the specific heat capacity and molar heat capacity with some examples. So I have taken some data here for water. Water is the substance with me, and specific heat capacity is this much. The heat capacity of water, but for how many grams of water I have taken it? For 100 grams of water, this is the heat capacity. And this is the molar heat capacity. Obviously, it is for the 1 mole of a substance. Correct? So let us understand it one by one. So when we talk of actually 4.186 joule per gram per Kelvin, my dear friends, it means 4.186 joules of heat is required to raise the temperature of how many grams? 1 gram. Temperature of 1 gram of substance, or we can say temperature of 1 gram of substance is here water, by 1 degree Celsius, or you can write down by 1 Kelvin. So this is our specific heat capacity, my dear friends. How much of heat is required? 4.186 joules of heat is required to raise the temperature of 1 gram of water by 1 Kelvin. Now my dear friends, here in this example, if you look, okay, you have a look here, it is 418.6. This was 4.186. So actually what I have done, I have taken that one. This is for how many grams? For 1 gram of water, how much heat is required? 4.186 joules. So this is actually the heat required, okay, to raise the temperature of 100 grams of substance. Which substance I am talking about? 100 grams of water by 1 Kelvin or by 1 degree Celsius, my dear friends. So this 100 gram is basically a given mass here. And I did not mention this gram in the formula, it's just joule per Kelvin. That means a mass is given to you, how many grams? 100 grams of mass is given to you. And you have to raise the temperature of 100 grams of water by 1 degree Celsius. Yes, so obviously it's a heat capacity because specific amount is not given. Specific amount is here 1 gram. Yes, so you are taking 100 grams. So it will reveal the heat capacity of a substance, that is water. So obviously this expression is nothing but it will be for 1 gram how much is required the heat? 4.186 grams is required for 4.186 joules is required for 1 gram. So for 100 grams how much of heat energy is required? And you are knowing that 418.6. It is nothing but actually it has come from this expression. 4.186 joules is for 1 gram. So multiplied by 100. So this will be the expression here. So 4.186 is for 1 gram of substance, heat required for 1 gram of substance. And now multiplied by 100 means the heat required for the 100 grams of substance to raise the temperature by 1 degree Celsius, my dear friends. So obviously, now look here, my dear friends, if you look here, you will find out that this is the molar heat capacity. It's with respect to 1 mole. Okay. So how can we understand that it's with respect to 1 mole? Have a look. Actual expression is like that. You try to understand. This is the heat required to raise the temperature of 1 mole of substance. That substance is water by 1 Kelvin. So this much of heat is required to raise the temperature of 1 mole of water by 1 Kelvin. So it's called as molar heat capacity, my dear friends. I hope everybody has understood this particular thing. Okay. And you know that 1 mole of water, if you look at, if I take 1 mole of water, how much is the mass of 1 mole of water? That is 18 grams. So my dear friends, we know that 1 mole of water is 18 grams. And you know that for 1 gram, how much energy is required? 4.186 joules is required. So for 18 grams, how much is required? So this expression will come from, my dear friends, 4.186 joule. This energy is required for 1 gram. But 1 mole of water is equal to 18 grams. So I will multiply it by 18. So this will be the outcome of that 75.348 joules per mole. So this 8 will represent actually, this is the heat required for raising the temperature of 1 gram of water. Multiplied by 18 means heat required to raise the temperature of 18 grams of water by 1 degree Celsius. And 18 grams of water is equal to what? 1 mole. And we know here 18 grams of water is equal to 1 mole. So my dear friends, I hope you have understood. Yes. So please make note of this. So dear friends, this is the specific heat capacity, my dear friends. And this was the amount of heat, 4.186 joules of heat is required to raise the temperature of 1 gram of water by 1 degree Celsius. And we know how much heat is required for 1 gram of water, that is 4.186 joules. Then how much heat is required to raise the temperature of 100 grams of water? That will be for 1 gram, we know it is 4.186 joules. So for 100 grams, so multiplied by 100. So I will get the result here. So how much of heat is required? 418.6 joules of heat is required to raise the temperature of 100 grams of water by 1 Kelvin. That means 418.6 joules of heat is required here to raise the temperature of 100 grams of water by 1 Kelvin. And we know that for 1 gram of a substance you require 4.186 joules of heat to raise its temperature by 1 degree Celsius. And you know here you have to raise the temperature of what? 1 mole of water. And you know that 1 mole of water is equal to how many grams? 18 grams. So we know heat required for 1 gram is 4.186. So for 18 grams is what? Multiplied by 18. So you will be getting 75.348 joules. So that means how much of heat is required here? So I will write down here 75.348 joules of heat is required to raise the temperature of 1 mole of water by 1 Kelvin. So with this, I would like to end today's session. Have a great time. May God bless you. Yo yo.